welcomes you once again for an interesting learning session. So today we are going to learn about circles for Class 10 CBSC Mathematics, Chapter 10, Part 1. The road to success does not depend upon the shoes we wear, rather the steps we take. So let's take good steps from Brahma Kumaris and let's move on. So these are the reasons why we took this video. Moving on to the next slide. So let's enter into the class. So what is circle? Circle is a collection of all points in a plane which are at a constant distance from a fixed point. So the constant distance in here is known as the radius, and the fixed point in here is called as the center. So when you observe the first picture, you see that the line PQ does not touch the circle. So the line PQ with respect to the circle is known as non-intersecting line with respect to the circle. Okay, in the second picture, you see that the line PQ intersects the circle at point A and B. So in this case, this line PQ is known as the secant of the circle. So next, in the third picture, we see that the line PQ touches the circle at only one point, and it is known as the tangent to the circle. So in the first picture, the line PQ is known as the non-intersecting line with respect to the circle. In the second picture, we call the PQ line as a secant of the circle. And in the third line, we see that PQ is the tangent of the circle. So now, can you see a pulley in here? So where do we use pulley? We use pulley to fetch water from the well. You see two lines coming from the pulley, that is the rope. The ropes are like a ray from the circle. So these two ropes are known as the tangent to the pulley because it intersects with the circle at only one point. So whether like any other things like for first and second, does anything sets this? No. Only the third thing, that is the tangent, sets the pulley. So moving on to the next slide. So tangent to a circle. A tangent to a circle is a line that intersects the circle at only one point. That is, if you take this line A dash, B dash, you could see that it intersects with the circle at only one point P. So A dash, B dash is a tangent. So now, take A dash, B dash from this side to this side. You see that after every moment, there are two intersecting points, right? So, and when you take this A dash, B dash from this side to this side, similarly, you can see the secant intersecting points. So, there's only one tangent at a point of a circle. So, A dash, B dash, the only tangent in this place. So next, while doing activity above, so this is the activity, you must have observed that as the position AB moves towards the position A dash B dash, that is this line AB moving towards the A dash B dash, you could see the common point Q moving towards the intersecting point P, like Q1, Q2 and Q3. When you see A double dash, B double dash moving towards A dash, B dash, similarly, the common point R3 moves towards the point P, like from R3 to R2 to R1, okay? So, the tangent to a circle is in a special case of a secant when two endpoints of its corresponding chord coincides, okay? So, moving on to the next activity. So, take a paper and draw a secant called PQ. This is the PQ. Okay. a secant called PQ, and draw various lines parallel to the secant on both the sides. You will find after some steps the length of the chord cut by the lines will gradually decrease. Could you see? This PQ line is very long, and this line here is very short. So when moving from this side to this side, or from this side to this side, you could find the chord decreasing. Then the 2 points of intersection of the line and the circle are coming closer and closer. Okay, in one case it becomes 0 on one side of the secant, and in another case it becomes 0 on the another side. So you could see that the secant, this PQ secant, becomes intersecting at only one point and becomes a tangent. Here in this side, the PQ at last becomes P dash Q dash as a tangent to the circle. Therefore, there is a two tangents parallel to the given secant. So this helps you to see that there cannot be more than two tangents parallel to the given secant. So there is no more than two tangent parallel to the given secant. Okay, moving on to the next activity. Could you see a wheel here? This wheel has many radii along it. Note the position of the wheel with respect to its movement on the ground. Does it have any tangent? Yes, as the ground touches the wheel in only one point. So it is a tangent to the circle. Okay. Also notice that all the position, the radii through the point of contact with the ground appears to be the right angle to the tangent. So you could see that this becomes, when this radii comes down and touches the tangent place, the intersecting place, you could find each radii give 90 degrees. Okay, so now moving on to the theorem 10.1. So they have given that there is a circle, OP is the radius, XY is the tangent, and you need to prove that OP is perpendicular to XY. So for that, you need to take a point Q on XY. Note, if XY is inside the circle, it is then called as the secant and not the tangent to a circle. Okay, therefore you can find that OQ is longer than OP because OP is the radius and OQ is more than the radius. And you could find that the point except the point of the radius to the perpendicular side, other lines are greater than the radius. Therefore, OP is the shortest. Okay, the distance of point O to the point XY, so OP is the perpendicular of XY. Okay, so moving on to the next question. Yeah, we are moving into the exercise 10.1. How many tangents can a circle have? So there are many tangents that a circle have because this circle has infinite number of points collected together to form a circle, and each point has its own tangent. So there are infinite points and infinite tangents. Okay, a tangent to a circle intersects in only one point, because if a line intersects the circle at 2 points, it is known as secant. Okay, a line intersecting a circle in 2 points is known as the secant. A circle can have two parallel tangents at the most. You have seen in the activity 2 where you took a paper, drew a secant PQ and also drew many parallel secants for PQ, and you saw that P dash Q dash and P double dash Q dash are the only parallel tangents to the secant PQ. the common point of a tangent to a circle, and the circle is called as the point of contact. The place where the tangent meets the circle, that one point, is known as the point of contact. Okay, so a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O. Okay, at the point Q. So that OQ equals 12 centimeter. They have given the radius and the hypotenuse. So you need to find the other side. That is, you need to find PQ. So you need to use Pythagoras theorem. As you know, this OP is perpendicular to the tangent and forms a 90 degree here. So it is a right angle, and you need to use the Pythagoras theorem. OP square plus PQ square equals OQ square. But you don't know PQ, so you need to take OP from this side to that side and then calculate. You get PQ as root 119 centimeter. Okay. So next, draw a circle and two lines parallel to the given line such that one is tangent and the another a secant to the circle. So this is a circle. You need to take you need to draw a circle, then draw a secant XY and a tangent to the circle. The intersecting, the point of contact you name as C, and you see that AB is parallel to XY, hence done. Thank you for watching this video. Subscribe, like and share, and give a thumbs up if you like it. If you have any doubts, please write it in the comment box. Your mind is powerful thing when you fulfill it. With positive thoughts, your life will start changing. So, from Brahma Kumaris, and the part 2 will get released in the next video. Please see that video for better understanding. Thank you guys. Bye.